Hi there, and welcome to this lesson. Now, in this lesson, we're learning basic algebra, okay? And under basic algebra, we're learning the properties of algebra. This should serve as an introduction to algebra. Basically, we'll learn what algebra is, and we'll learn the different operations we can perform in algebra. Now, as the lesson progresses, if you have any issues at all, anything comes up as unclear, please feel free to get in touch, okay? We would be more than happy to help. Okay, so let's jump right into the lesson. So basic algebra, the properties of algebra. Now, what exactly is algebra? Now, algebra is a part of mathematics that uses letters to represent certain quantities in equations and expressions. For example, you could have an equation like this. You have a plus 1 equals 3. What is this about? A plus 1 equals 3. Now this is an equation, okay, and it's basically asking you what would you add to 1 to give you 3. You can actually represent this in this form. You say dash plus 1 equals 3. What would you add to 1 to give you 3? And if you solve this, and I believe you'd agree with me, that 2 plus 1 gives you 3. So in this case, A is 2. And this is pretty much the foundation of everything we're going to do in this course, because it does get more complicated than A plus 1 equals 3, because in mathematics we have more complicated problems and we use algebra. We often represent certain unknowns with letters to solve for said unknowns, and yeah, that's pretty much what we're going to be doing all through the course, and that is algebra. We need to get familiar with some terms, okay? And basically we start off with variables. Now, what are variables? Now, variables in algebra are quantities that are not fixed. Now, pretty much every letter you'd find in algebra is a variable, okay? You can have a, x, y, pretty much any letter we use in algebra is a variable. Now, what about terms? Now, an algebraic term represents an individual unit in an algebraic expression. So, for example, you could have an expression 2x plus 5 plus y, and basically 2x is a term, 5 is a term, and y is a term, and they all form an algebraic expression. Now, coefficients are numbers that multiply variables in algebraic terms. Okay, for example, you could have an algebraic term 2x, okay, and basically 2 is multiplying x in the term 2x. 2 is the coefficient of x in the term 2x. It's that simple. So what about algebraic expressions? Now, an expression consists of a group of terms with one or more arithmetic operation. So you have two terms, 2x and y. Okay, so 2x plus y, or 2x minus y, or 2x of it's an algebraic expression. Okay, so now let's talk about like terms. Now, like terms are terms that contain variables that are exactly alike. Now, what does this mean? So we have two terms here, x and 2x. Now, x has the variable x, 2x has the variable x. These are like terms. 3y and 11y. 3y contains the variable y, 11y contains the variable y. These are like terms. Let's go on. X and 7y. These are obviously not like terms because x contains the variable x and 7y contains the variable y, and x and y are not exactly alike, so these are not like terms. Now, what about 2x and x squared? Now, it gets interesting here. Now, 2x and x squared. Now, 2x contains the variable x, and x squared is, yes, contains the variable x squared. Now, I tell you that these are not like terms, okay? X and x squared are not exactly alike, okay? X squared and x cubed are not exactly alike, and as such, they are not like terms. What about 17x squared and 5x squared? Now we have x squared and x squared, and yes, these are like terms. So What is the relevance of this? Basically, like terms. Why are we talking about like terms? Basically, these apply to basic operation on algebraic terms. You can add and subtract like terms. Okay, just keep that in mind. So let's talk about addition of algebraic terms. So if you have x and x, these are like terms, you can add them up and it gives you 2x. So just like you'd have 1 plus 1 gives you 2, x plus x gives you 2x. Y plus y gives you 2y. Y plus 6y gives you 7y. Okay, so just think of it as 1 plus 6 equals 7. Y plus 6y equals 7y. Okay, think of it as 1 apple plus 6 apples equals 7 apples. Okay, so y plus 6y equals 7y. Now what about x plus y? Like I said, you can only add and subtract like terms, and because x and y are not like terms, there's no solution to this. Okay, so you can't perform addition and subtraction on x and y. Okay, so so there's no solution to that. What about 3x plus 2x? Now 3x plus 2x equals 5x, and then x plus 7, you can't do that as well. Okay, you can't add a variable to a number. Okay, so x plus 7, there's no solution to that. Now let's talk about subtraction. Now we have subtraction. 2x minus x equals x. Okay, so like you take out 1 apple from 2 apples, you have 1 apple left. So 2x minus x equals x, or 2 minus 1 equals 1. 2x minus x equals x. Oh yeah, something we need to take note of. Basically, if you have 1x in algebra, or 1y, or 1m, you just represent that as x, y, or m. Okay, so anytime you see just x, know that x represents 1x. And 2y minus y equals y. 15x minus 8x equals 7x. Just like you would subtract 8 from 15 to give you 7, you would subtract 8x from 15x to give you 7x. Y minus y equals 0. Okay, so you subtract the variable from itself, it gives you 0. And what about x minus y? Like I said, you can perform addition and subtraction on like terms. So, and because x and y are not like terms, you actually can't do that. And then you have y minus 12. Similarly, you can't subtract a number from a variable, so you have y minus 12, and there is no solution there. Okay, so let's talk now about multiplication. Now, multiplication is pretty much the easiest operation in algebra because you can multiply pretty much anything. You can actually multiply everything. Okay, so x times x is x squared. Okay, x times x is x squared. We write it that way, just like you have 5 times 5 is 5 squared. X times x is x squared. Y times y is y squared. X times 2 is 2x. Okay, so basically 2x is 2 multiplying x. 2 apples, 2 oranges, think of it in that manner. And then we have 3 times 4y. Okay, so how do we move? Now we have a number and we have a term with an algebraic expression that has a coefficient. So we have 3 times 4y equals 12y. So basically we have 3 times 4, 12 times y. Okay, just think of it as you have 4 apples and you have 3 sets of them. How many apples do you have in all? You have 12y. Now, what about x times y? Like I said, you can multiply pretty much everything in any algebraic terms. So if you have x times y, it gives you xy. You just write it as xy. If you have 7x squared times 2xy, now pay close attention, you basically multiply the numbers, the coefficients. So 7 times 2 equals 14. X squared times x equals x cubed, and finally you have y. You just put it all together. So you, like I said, you can multiply everything. You can actually just split those down. 7 times x times x times 2 times x times y. You multiply everything out and it gives you 14x cubed y. So yeah, in algebra you can multiply everything. Keep that in mind. Now what about division? So x squared divided by x equals x, y squared divided by y equals y, 2x divided by x equals 2. Okay, so 2x divided by x equals 2. The x cancel out, and 21y divided by 3y equals 7. Okay, the y cancel out, and then you have 21 divided by 3 equals 7. And you have 3xy divided by y equals 3x. The y cancel out, and the y's cancel out, and then you have x divided by y. You can't do that. There's no solution to that. X divided by y is x divided by y. And yes, that brings us to the end of basic operations on algebraic terms. Now let's go ahead and do some examples. Now, example 1, and example 1 says simplify 5x plus 2 minus x. Now, I'm going to introduce something to you. So we have a fairly complex expression here. So it says 5x plus 2 minus x. And we've been asked to simplify this. Now, how would we go about doing this? What we're going to do is we're going to collect like terms. Okay, so we have 5x plus 2 minus x. We can't add 2 to 5x, okay, but we can definitely subtract minus x from 5x. So when you have an expression like this, what you do is you bring the like terms together. Okay, so I'm going to bring minus x, and anytime you're moving terms around, they usually go with a sign in front of them. So I'm going to move minus x over to the left, okay, and I'm going to move it closer to 5x, and what I have is 5x minus x plus 2, and what I have in the end is I have 4x plus 2. Okay, let's do another one. Example 2. And example 2 says simplify 3m plus mn squared minus m plus 5n squared. You need to be careful here. Okay, and let's look closely at this. We need to collect like terms here, and we have 3m mn squared minus m and 5n squared. Careful now, because mn squared and 5n squared totally different, 3m totally different. The one we actually have just a pair of like terms here, and what we have 3m and minus m, and we're just going to bring those closer together. Okay, so we bring minus m over to the left, and we have 3m minus m plus mn squared plus 5n squared. And what we have is we have 2m plus mn squared plus 5n squared, and that is our answer. Okay, let's move on. Now, example 3. And example 3 says evaluate p minus pq over 6. Okay, so p minus pq over 6, use p equals 6 and q equals 5. So what does evaluate mean? It just tells us to put those numbers into the expression there. Okay, so we have p minus pq over 6, and we've been told that p is 6 and q is 5, and we're just going to plug those numbers in, and basically we have our expression. We plug those numbers in, p 6 for p and 5 for q. So anywhere we see p we put 6, and wherever we see q we put 5, and so we have 6 minus 6 times 5 over 6. And what we have is we have 6 minus 30 over 6, and we have 30 divided by 6 is 5, and you have 6 minus 5, and it gives you 1. Simple, straightforward. Let's move on. So example 4, and this is our final example, and it says evaluate k times 3 squared minus j plus k if j is 4 and k is 5. Now it's pretty much the same, okay, but we do have an expression here that needs to be simplified, okay, before we plug our numbers in. So we have k times 3 squared minus j plus k minus 5. Now how do we go about doing this? First, let's simplify. 3 squared is 9, so we have k times 9 minus j plus k minus 5. Okay, and then we'll multiply. K times 9 is 9k. Okay, and then we'll open up that bracket. Okay, so we have 9k minus j plus k is the same as 9k minus j minus k minus 5, and then we have 9k minus k minus j minus 5. Okay, we'll bring k over to the left. Okay, we collect like terms, and what we have in the end is we have 8k minus j minus 5. And yeah, so we've simplified, and now we need to plug those numbers in. So 8k minus j minus 5, and we're plugging in 5 for k and 4 for j. And when you do that, you have 8 times 5 minus 4 minus 5, and what you have is you have 40 minus 4 minus 5. You have 40 minus 9. Okay, minus 4 minus 5 is minus 9. 40 minus 9, and what you have is you have 31. And yes, very simple, very straightforward. And that will bring us to the end of this lesson. Very simple lesson, fairly short lesson. And yeah, bye for now.